Alright, today we are doing 6-6, operations on functions. Today's date is today, and our objective is to perform operations on functions and determine the domains of the resulting functions. Alright, these are the functions that we're going to be doing: adding, subtracting, multiplying, and division. If I were you taking notes right now, I might hit the pause button so that you can copy this down into your notes. So let's go ahead and do some examples. I've got my f function, f of x equals x squared minus 2x, and g of x equals 2x. Remember, this is function notation. That's just a fancy way of saying, hey, I've got a function, and instead of y, I'm going to write f of x. Same thing with the g of x. That's just a fancy way of saying y. So on the first one of a, I'm just going to take my f function and add my g function. So that would just be 4x squared minus 2x plus 2x. And what happens is it looks like those 2x's are going to cancel out, and I'm going to get just 4x squared. Let's do another one. F of x minus g of x. So you write down your f function. What I usually do, though, is if I'm subtracting a function, I'll go ahead and put parentheses around the whole function, because if there's more than one term, you need to distribute that minus sign. And when I simplify it here, I'm going to get 4x squared minus 4x. Let's do one where we multiply. Take your f function, and that's going to be multiplied by your g function. Well, looks like I'm going to have to distribute here. And when I do that, I'm going to get 8x cubed minus 4x squared. And our last one, we're going to take our f function and we're going to divide it by our g function. Sometimes you're going to be able to do this, sometimes you're not. But I notice on the numerator, I have a greatest common factor. I can factor out a 2x. And when I do that, I'm going to get 2x minus 1. My 2x's are going to cancel, and I'm going to be left with 2x minus 1. However, when I look at this, I notice I have a denominator. And one thing that we've learned is you can never have 0 in the denominator. So 2x can never equal 0, or x cannot equal 0. On this one, I'm going to have to give my domain because x cannot equal 0. Even though it's simplified, if I looked at the original and I had x equals 0, I would have an undefined situation. Let's do another one. I've got f of x equals 4x plus 8. G of x is 2x minus 12. So on the first one, if I want to add them, I'm going to get 4x plus 8 plus my g function, 2x minus 12. Go ahead and combine like terms. 6x minus 4. Let's go ahead and do number 2. My f function minus my g function. And on this one, I'm going to make sure I put that in parentheses because I have to distribute that minus sign. I'm subtracting the 2x and subtracting that negative 12. So that's the same as 4x plus 8 minus 2x plus 12. I'm going to get 2x plus 20. All right, number 3 looks like a multiplication problem. 4x plus 8 times 2x minus 12. Well, looks like I'm going to have to FOIL on this one. 8x squared minus 48x plus 16x minus 96. Go ahead and combine like terms. 8x squared. Looks like negative 48 plus 16 would be negative 32. And our last one, that would be 4x plus 8 all over 2x minus 12. I'm already thinking I'm going to have to give my domain on this one because it's not going to be all real numbers. 2x minus 12, my denominator, cannot equal 0. Looks like x is not going to be able to equal 6. Let's go ahead and see if this simplifies any. You can factor a 4 out of the top. I can factor a 2 out of the bottom. And I'm going to be left with 2x plus 2 all over x minus 6. And x cannot equal 6. All right, let's talk about composition functions. You can see a new symbol here. That's that little f. And what that is means that you're doing a composite of a function. What you're really doing is plugging one function into another function. If I were taking notes on this, I would probably pause right now and copy this down. All right, so on this one, we've got g of f of 4. And I always like to rewrite it like this. And we're going to start with our inner part. We need to figure out what f of 4 is. So f of 4 just means you're taking 4 and plugging it into your f function. So that would be 4 minus 2, which is 2. So then I'm going to have to figure out what g of 2 is. Well, that would just be 2 squared or 4. Let's do another one. F of g of negative 1. So we're going to start with our inner part here, g of negative 1. And that would just be negative 1 squared, which is 1. So then figure out what f of 1 is. And that would be 1 minus 2, or negative 1. Let's do the last one here. G of f of negative 3. Now let's figure out what f of negative 3 is. That would just be negative 3 minus 2, which would be negative 5. So then we have to figure out what g of negative 5 is. Well, that would just be negative 5 squared. We can do that one in our head, which would be 25. All right. Let's go ahead and do a couple more. I think in class we did these ones on your own, but I'll go ahead and do them with you right now. So find f of g of 2. Well, g of 2 would be 2 plus 1 over 2, or 3 over 2. So I need to figure out what f of 3 over 2 is. So let's go ahead and do that. That would be 2 times 3 over 2 squared minus 3. Order of operations. Square your exponent first before you multiply. That's going to give me 18 over 4. Well, let's reduce that. we should reduce first. Because those 2's are going to cancel. I'm going to get 9 over 2 minus 3. When I'm subtracting, I have to get a common denominator. My common denominator is going to be 2. Looks like I'm going to get 3 over 2. All right, let's do another one. On this one, we need to figure out what f of negative 3 is. So that would just be 2 times negative 3 squared minus 3, which would be 2 times 9 minus 3. 2 times 9 is 18, minus 3 is 15. So we need to figure out what g of 15 is. Well, that would just be 15 plus 1 all over 2, which is going to give me 8. All right, I'm going to go ahead and skip this example for the moment. I hope you enjoyed.